Alright, so in this one we want to simplify this thing. What we see is we have 5 times the square root of x minus 3 times the square root of x. And so what I recognize is that there is something that is multiplying both of these terms. There's the square root of x that's multiplied into both things. So we can reverse the distribution here, right? So if I pull out a square root of x, I'm left with the 5 in my first term, and I'm left with this minus 3 in the second term. Well, 5 minus 3 is equal to 2, so this whole thing is either the square root of x times 2, or in more formal notation, regular notation, I would write this as 2 times the square root of x. Now for b, we have kind of a messier expression, right? We have negative 2 times the square root of 9y plus 10 times the square root of y. Okay? Now, one thing we know is that roots and multiplication play nice. So I can actually break up this expression, this first term, as negative 2 times the square root of 9 times the square root of y plus, and then I haven't done anything with this other term, so I'm going to leave it as 10 times the square root of y. Okay. Now, the square root of 9 I can simplify to be 3, so to be very careful and pedantic about this, this is negative 2 times 3 times the square root of y plus 10 times the square root of y. Okay. So now I can multiply my negative 2 and my 3 together, getting negative 6 times the square root of y plus 10 times the square root of y, and now I can do the same exact thing that I did in part A. There's a square root of y in both terms, so I can reverse the distribution, or I can pull it out, as I like to say. This is going to be square root of y multiplying this binomial minus 6 plus 10. Oops, that's a 10. But this is the same thing as 10 minus 6. 10 minus 6 is equal to 4, so this gives us 4 times the square root of y. We're done.